Hey chemistry students, welcome to your tutorial on solubility curves. So I have drawn out for you a solubility curve. Notice that the y-axis shows solubility, so how many grams of my three substances will dissolve in 100 grams of H2O or water. And I have that for various temperatures and degrees Celsius on the bottom. So I have some questions and we are going to work through them together. Alright, so my first question, how much KBr will dissolve in 100 grams of H2O at 20 degrees Celsius? So when I'm looking at this problem, I first want to locate my solubility line for that substance. So here is my line for KBr. And I'm asked how much will dissolve in 100 grams of water at 20 degrees Celsius. So I found my line. Now I'm going to find that temperature. And I'm going to move straight up until that point meets my line. So at 20 degrees Celsius, I hit my line. So now what I'm going to do is mark over to my y-axis. So this could be anywhere. This is the 60 line, this is the 80, and this is the 70. So we are around, let's say, 67 grams will dissolve at 20 degrees Celsius. Alright, for our second question, at what temperature will 30 grams of YB2SO43 dissolve in 100 grams of water? So step one, going to find my line. So here's the solubility line. Notice that it's different from my line for KBr and KNO3 in that my solubility line for this substance goes down as I increase my temperature. So that's interesting to note. So I'm asked at what temperature will 30 grams of my substance dissolve? So this time I'm starting with a mass. Here's my 30 line. And I'm asked at what temperature will 30 grams of my substance dissolve. So I'm going to start at my 30 and I'm going to move over until it meets my line. I'm going to do my little dashes down. So that's anywhere around maybe 18 degrees Celsius. And I want to note that. So 18 degrees Celsius. Alright, another type of question we encountered dealt with saturation, unsaturation, or supersaturation. As we discussed in class today, if the point that you're given falls right on the line for your substance, we classified it as saturated. So this is also a line of saturation, meaning it has the maximum amount of solute dissolved in the solvent. We stated that if our plot fell below that line, it meant that our solution was unsaturated, so not enough solute was dissolved. If our plot comes higher than the line of the substance we're dealing with, that would be supersaturated. And in that type of solution, you would start to see crystals form. That solution is very unstable. No more of the solute can dissolve. So we're going to use that to answer question 3. So 50 grams of KNO3 in 100 grams of water at 30 degrees Celsius. I'm asked saturated, unsaturated, or supersaturated. So I need to find my substance line. So this is the line for KNO3, which we're going to learn to name all of these later on. So here's my line. Now I'm asked 50 grams. So here's my 50 grams at 30 degrees C. So I'm going to find the point where 50 and 30 cross, and I know it's a little hard because my makeshift graph doesn't have all the lines like yours. Okay, so I plotted my coordinate. 50 grams, 30 degrees Celsius. May not be spot on, but it's okay. We'll roll with it. So now, here's my substance line. And again, anything along this line is saturated. So if I made a solution that contained around 35 or 38 grams of KNO3 at 30 degrees Celsius, I would have a saturated solution. But the solution I'm trying to make has 50 grams at 30 degrees Celsius. So my plot is actually above my line, so it would be supersaturated. So what I'd like you to do is go take a look at your practice packet, go back and look at the finisher or the starter that deals with solubility curves, and use this tool to help you in studying. If you have any further questions, just let me know during class.